environment.
Maybe, is it like the flow of the work?
Flow of the work, yeah. Like the physical. Today's lecture is about the physical. To
Like maybe do step by step work, maybe. Like, yeah, and more effective or.
Okay, yeah, it can be. Another?
Then about also improve projective,
Improve project
productivity.
productivity. Okay, productivity. Yeah, of course, it have to increase the productivity. But what kind of thing that support the work environment design?
Maybe is it lighting?
Lighting. Yeah.
Machine.
Machine. Okay.
Then
What else?
maybe temperature, and then
Temperature. Yeah. Probably.
Is it layout?
Layout. Yeah. But not right now. But it can be. Any? Any?
yeah, equipment maybe.
Equipment. Okay. Let's start the lecture. Okay. First, it's about lighting, noise, temperature. Yeah, you already mentioned it. The heat, the cold, the vibration. Sometimes it can be annoying. Radiation. Shift to optimize the productivity, and training to ergonomics and safety. How to train the ergonomics and safety. Okay. Okay. For the shift to optimize the productivity, we already learned it in biology. Circadian rhythm, you still remember? Yes, circadian rhythm about shift to optimize the productivity. Okay, first, yeah, the value of the good environment. Plants with good working condition, plants like the organization with a good working condition, outperform those with poor condition. Yeah. Economic return on investment (ROE). Yeah. In better condition is usually significant. How can it be significant? It improves safety and morale. It reduces the turnover and absenteeism. Yeah, because the workers can get the healthiness. The worker can get the comfort. Yeah, so it can reduce the turnover and absenteeism. Failure to comply result in OSHA fines, yeah, OSHA, the Occupational Safety and Health Administration. Okay, then the home environmental design. Many of the same principles that apply to environmental design of the workplace also apply to design of the home. Yeah, we want get our home comfort. We want get our home healthy with a nice circulation or something like that. So it has the same aim that we want to get a healthiness in our workplace. Issues such as lighting, heat, ventilation, layout, and adequate space for tasks can have great impact on the convenience, efficiency, feelings in one's home. Yeah, sometimes we feel like I'm in our homes. Yeah, we want to make our office as comfort as our home and as health as our home, as healthy as our home. Yeah, feeling in one's home. Is it a welcoming, relaxing event, or is it a chaotic or stressful? Okay, first is about the lighting and illumination. Lighting intensity. The lighting intensity is measured in candelas, CD, or lumens. Yeah. With one candelas is same with 0.57 lumens. We have to make differences between the lighting intensity and the illuminance. Yeah, this is the illuminance, and then after this we talk about the luminance. Yeah, illuminance is the amount of light shining on an object. So this is the differences. Measure in foot candelas, FC. So the illuminance is same with the intensity per d square. D is the distance. Yeah. Intensity per distance square. Where D is in feet, so intensity is in foot candelas. Where 1 foot candelas is same with 1 lumen per feet square. Okay. So lighting, intensity, then illumination. Then we talk about luminance. Yeah, illuminance and luminance. Luminance means the amount of light reflected from an object. Yeah, we come back to the illuminance. Amount of light shining on an object. And the luminance is amount of light reflected from an object. Okay? You get it? Okay. It impacts our ability to see the object. Because when we want to see an object, the object must be reflect the light. Yeah. It is measured in foot lamberts, FL. So luminance is equal with illuminance multiplied with reflectance. Yeah, and the reflectance is determined by the physical and color properties. Yeah. I mean, like it influenced by the physical and color properties, yeah, of an object. How much light is absorbed or thrown back at the viewers? It's depend on the color. It's depend on the surface. It's depend on the shape of the object. Yeah.
So, is there any formula to calculate it?
After this. Reflectance is the property of a surface which is determined by both color, we see in here is blue, and we see in back is red. Yeah, it's different reflectance. Yeah, and surface finish. Yeah, sometimes we see it can be a bit rough, or it's slippery. Yeah, the surface sometimes slippery, or sometimes rough, or it can make like a wavy or something. Yeah, and expressed as a percentage of light reflected or luminance. And luminance is measured by a photometer pointed at the surface. We can see like center itu kita flashlight Yeah, we directly to the object and then we can calculate it, the number. Yeah, it is a photometer pointed at the surface. Table 6.1, yeah, lists reflectance for various colors and surface. Reflectance is the ratio between the measured reflectance of the target of surface and the measured reflectance of the standard Kodak neutral test card 0.9. So this is the constanta. 0.9 is the constanta. So the reflectance is equal with 0.9 multiplied by L target per L standard. Luminance target and per luminance standard. Okay? Did you get it? Okay. Then the reflectance of typical paint and wood finish. Yeah. Why? It's the best reflectance. Yeah. The percentage of reflected light is 85. Colors like medium blue, yeah. This medium blue is sometimes it's not good for reflect. Yeah. When the light is not really shiny, not really shiny, it can be difficult to see the object if the background is blue. It's different with the gram. Light gram is 75, light gray is 75, but medium gray is just 55. This is the list. Okay, after all the luminance, and then we talk about the visibility. The visibility is the clarity with which a human can see an object. The visibility is the clarity with which a human can see an object. There are three critical factors in visibility. First is visual angle. Second is the contrast. Contrast is include the color, and then the illuminance. Visual angle, contrast, and the illuminance. How much? The lighting. What is illuminance? How much? Lighting. Yes. That what? Reflective or?
Shine.
You can back to the slide, previous slide. Okay, then, yes, but do I have enough light on my task? That is the question. The amount of light needed is a function of the first, the nature of the task. Is the task is need what is it? Accuracy, like accuracy, high accuracy. Like you want to make a threads and needle to, yeah, you need so much light in that task, or a job with something, a small particle, yeah, or something. Yeah, it's depend on the task. So we call it the nature of the task. And then second is the worker, age, and the visual health. If the worker is young like you, it will be okay. Not much lighting, but you're still young, it still be okay. But it will affect to your health. Of course, for your visual health. The reflectance of the task background. The reflector of the task background, like in here. If this is black, sometimes it can be absorbed the lighting. Yeah. The table 6.2 shows how much light in 5 candela is needed for different types of tasks. Yeah. How much light is needed? This is the table 6.2. Will give you a range of lighting level: low, medium, high. Yeah. You can see a task, for example, visual task with low contrast and small size Example, pencil writing on low quality paper. So we can categorize with F, but the problem is in here, the range of illuminance. Low, medium, high. Is it low or is it medium or is it high? We don't know. Yeah. To choose between low, medium and high, we use table 6.3. Okay, example for lighting problems. The H&R, Human and Resource Department, yeah, for the tax preparation company, hires retired people, 60 plus years old people, to prepare taxes from January through April. The task must be done with reasonable speed, particularly in April, and high accuracy. The notes people give to their tax preparers range from high quality printed receipts to handwritten pencils, notes on yellow notebook paper. So the yellow notebook paper is a low contrast, right? So the question is it sufficient to light the tax preparer's desk with a single 800 lumen incandescent bulb? Bulb is just 800 lumens. If the bulb is 5 feet above the worker desk, just 5 feet, and the surroundings are cream color, so you have to pay attention to this question because sometimes it can be appear in our test. Light output intensity in lumens or candelas can often be found on the bulb packaging. Yeah, we can see when we buy a bulb from the shops, electric shops or something, we can see, is there any information about the lumens or watts? 5 watts, 10 watt. Example lighting problems. Consider this question in 2 parts. First is how many feet candelas are needed. And second is an 800 lumens bulb sufficient to provide the illuminance if the light source is 5 feet from the wall. Okay, first question. We have to answer the first question with how many feet candelas are needed. Find reflectance of surroundings. Yeah, we have to see the table 6.1 first to see the find reflectance of the surroundings. Light cream give you approximately 75, right? Now 75% reflectance. And then look in table 6.3 for a weighing factors based on the task characteristic, the age of the worker, the reflectance of the surrounding, and the critically, the job or the task needs speed and accuracy. So we have to make the value and the weight. We have to make the weight to the task. Yeah. Okay. The total weight. The total weight in here is +1. So look in table 6.2 to find amount of light needed. Use weighting factor to pick illuminance value. For low is -3 and -2. For medium is -1, 0 and +1. But for the high, illuminance is +2 and +3. So the weight is +1. So 1 is required a medium illumination. I think the table 6.2 is not really complete. You can see in just surfing in Google or something or ask the GPT to the table.
How do we conclude with the weight, like the age of worker? How do we know that it is +1 reflectance, -1?
It is the subjective.
Subjective.
Yeah, by our subjective. Actually, you can see in the 6.3. have the 6 tables, but it's not really complete in this slide. So probably you have to sort by yourself. But 2 make it +1, -1, and like this, it depends on our subjectivity.
So the result will be subjective also, like the median.
Yeah, but we have the parameters in the table.
Okay.
Like the manual material handling in a poor, medium, or poor and good, poor and good condition or fair condition. It depends on our subjectivity, but we have the parameters. How to make it poor or how to make it fair or good. Sometimes it's different between us. Perhaps you can choose fair or Fakela can choose good. Sometimes it's, but even though we already know the parameters, but to calculate in years, in this, sometimes it depends on our subjectivity. But if you're not really sure, we can give an information in the test questions. Yeah. Like in manual material handling, sometimes we already decide in questions that it is poor condition or it is in good condition. Okay? Now, the second question is an 800 lumens bulb sufficient? Is an 800 lumen bulb sufficient to provide 150 feet candelas on the work surface if the light sources is just 5 feet from the work desk, the worker desk? One candela equals with 12.57 lumens. Yeah, and then 800 lumens, so we have to multiply with one candela per 12.57 lumens, and we got 63.64 candelas. And for the illuminance, 8 candelas equals with the intensity per distance square. So 63.64 candelas we divide by 5 feet square, and we got 2.5 feet candelas. You got it? Okay? Okay. Yeah, this bulb at 5 feet is woefully inadequate. Okay for general lighting in a public area, but not for the speed and accuracy requirement jobs. Okay. Then the improving visibility. One can improve visibility in several ways. Increase the source of intensity, increase voltage, change the more efficient type, fluorescent or halogen, or we can use LED light to make it spark, but in cheap. Bring target closer to viewers. It's not really good actually, because sometimes when we work with like a personal computer like this, and then we bring the target closer to the light, you get your visual health decrease, of course. Increase contrast, increase target size, big print book, or etc. Factors in visibility. First is visual angle, the size of target on retina, the angle the image takes up on retina, because the shadow is small to our retina, right? Yeah. The contrast, relative difference in luminance, light reflected for two surfaces, illuminance amount of light reaching a surface is most important. The contrast. Contrast, relative differences in luminance, light reflected for two surfaces. Contrast can be defined in several ways. A common definition of contrast, we use unitless. Yeah. The contrast is equal with L maximum, the luminance maximum minus the luminance minimums per the luminance maximums. So where the L is the luminance of each surface, if there is two surfaces. Sometimes we mix the color, like dark blue with red in a slippery surface. Mix text with white text or black text in the background. Sometimes we just see like the text is moving. Jadi kayak kita tuh kalau ngelihat apa tulisan di background yang warna merah atau biru di permukaan yang licin, kertas yang licin itu kadang-kadang teksnya tuh kalau kita baca itu kayak gerak-gerak gitu. Pernah ya? Gitu ya. Nah, tuh pengaruh jadi kontras, the colors, yeah, can be defined in several ways. Yeah, common definition of contrast pakai unitless ini. And second is the glare. Yeah. Any area of excessive brightness with decreased visibility causes cornea or glasses to scatter light. Yeah, causes eyes to have to adjust the extreme bright area. If the area is too bright, we have to adjust our eyes. The same knowledge that we already learned in cockpit, you know, the cockpit area in an airplane. Why? If we on a night flight, the cockpit area is in red color, not in white color.
Because if the pilot drive in white color, it will hurt the pilot eyes because of the brightness.
Because of the brightness.
The contrast also.
Yeah, because our eyes don't have to adjust the extreme bright area.
Is it because like the red is the color with the less frequency?
Yeah, the less frequency. So we can comfortably adjust our eyes. Are you understand?
Yes, good. Also, I see here in the high buildings like Ergonomic building in Universitas Brawijaya. So there's like on the top, like there's added like
Oh, the other,
the
Signal.
yeah, like the signal.
the signal.
Yeah, but I asked like why it's red like this. Some of my friends they said they studied master degree. They said like because when the dents move, you can see this building is high.
Yeah, but actually not perfect explanation about that. Okay, I will close this for a minute and then I will show you something that makes you understand about this fractions. Ya, di sini ya sambil dengerin musik ya. is the visual angle, yeah, and the distance. Yeah, so the visual angles is 5.7 multiplied by 60 multiplied by the height per the distance. And this is the visual activity. In this. Okay. In industrial tasks where the light condition change from light to dark, sufficient time must be allowed for dark adaptation. Yeah. Human factors application. Why are red lights used in cockpits and dark rooms? Is because the rod are insensitive. The rod cells in our eyes. Yeah. The rods are insensitive to the longest wavelength, right? It didn't degrade dark adaptation. Here, the red concrete in here. Yeah. We have two cells in our eyes. Red, yeah, or rod cone in here. Sensitive. Now, in here there is an information about when moving from dark to light room, the human eyes adapt in a few seconds, but it takes up to almost 40 minutes to adapt from light to the dark room. So when in the cockpit, the pilot, it's in a dark area, right? If the lighting is so shiny, simmering second. Yeah, it's very difficult to make an adjustment for our eyes. And if the planes fly normally, it's just okay. But if the planes fly in an accident condition and the pilot get panic, there is so many displays and control. If they make a mistake to choose control or to choose the display, so it can be fatal to the flight. Kita kan punya dua sel ya, sel batang, sel kerucut ya di dalam mata kita itu. Nah ini, oke. Second activity. Causes eyes to have an adjusted extreme bright area. Causes light sources aimed at eyes. Reflectance of or work surface. Solution: change to indirect lighting. Yeah. Change lighting angle or work surface angle, use non-glare surfaces, yeah, and use polarizing filters on light sources or eyewears. Yeah. We can use black glasses or something, but sometimes it's not help when we are in the night condition. Other ways of improving visibility. Yeah. I'm sorry. I forget this book, so page 277. I will not include it in here. So the second is about noise and hearing. Noise, any unwanted sound. Sound is measured in decibels, which measure the amplitude of the sound wave. These decibels are measured on a logarithmic scale. In this, the wave some sound level, measure perceived loudness, combines both amplitude and frequency. The most widely accepted measure of sound. Now, to talk about noise, so we have to talk about hearing loss as well. From the OSA in 1970, limits for noise exposure are shown in table 6.68. In table can perhaps you can search by yourself from Google or something. The duration and the decibels. I'm not really agree with this. Actually, 8 hours must have 85 decibels, not 90. 90 is too high. So the 8 hours jobs with noise must be at 85 decibels maximum. So you have to Googling by yourself for these tables. Risk of hearing loss increases beyond this exposure. Workers may not be exposed to anything over 90 decibel for the duration of an 8-hour workday. I'm not agree with 90 decibels, but it have to 85 decibels. Nothing over 115 decibel is allowed at all. And we calculated the noise dose. The noise dose is the total exposure to any sounds above 80 decibels during an 8-hour day. The dose is 100 multiplied with C1 per T1 per C2 per T2 and etc. So where the D is noise dose, CI 1, 2, 3 and etc. is hours spent at a given noise level, and the T is hours permitted at noise level. D must be kept below 100% of permissible noise dose. You are exposed to 3 noise sources during your workday. 8 hours at 90 decibels, 2 hours at 95 decibels, or just half hour at 105 decibels. So your total noise dose, if you work different hours with different decibels. You have to calculate this. So is your hearing at risk? The question is, our hearing at risk? Yes. Then how to control the noise? Eliminate noise at its sources. Best but most difficult. Sometimes we still have to hear the noise. We don't have any choice to not hear it. Substitute quieter machines, hydraulic for pneumatic reverter or electric for gas power movers or something. Isolate the noise making equipment, rubber fit under equipment, separate room and closer. Absorb noise with sound absorbing materials on ceiling. Sometimes the ceiling. Actually, these rooms have to make absorbent, like the ceiling and the wall. So the kitchen or the canteen in there not affect our activities in this class. Okay, use hearing protection on workers. Using age-related differences in hearing. Mosquito thin repellent You know the mosquito tin wrap? Or the mouse repellent, it has the same same work machine. Product which emits a very loud or high pitch tone with teens can hear and most people over a certain cannot. Teens have used the rebel tone as a ringtone on the telephone so they can send messages to their friends in the class. You can try to listen at the tone at in here. Okay. Can you try?
Problem with surly teenagers congregating on your doorstep? If so, you can buy a device called the Mosquito Teen Repeller. It emits tones even higher than the one you just heard, or maybe didn't hear, and most teenagers can't stand it. But some clever teens have figured out how to use those high frequencies on their cell phones to dupe adults. To find out how all this came about, I went right to the source in Wales.
Howard Stapleton, Managing Director of Compound Security Systems and inventor of the Mosquito Teen Repeller.
Isabel Stapleton, daughter of the inventor of the Mosquito Teen Repeller.
Howard, tell me about this Mosquito Teen Repeller, how you got the idea, first of all.
When I was very young, I used to visit factories my father was the boss of. I went to one factory and they used a method called ultrasonic welding. I walked in a room with a group of adults and the noise was so loud and painful I walked out. The adults came out and asked me what the problem was and I said the noise and they went, "What noise?" I've been in the security industry some 18 years now and a local shopkeeper to me was having serious problems with a particularly malicious gang of teenagers who hung around his store, especially in the evenings. So I put my idea to the test.
Well, how does it work exactly?
Yeah, it produces a noise of around about 17 kilohertz, but the real trick to it is pulsing this noise on and off, and it just makes it really, really annoying after, as I said, 5 to 6 minutes, and the teenagers disappear. We've sold very nearly 1,000 units across the UK now. It's great.
Well, Isabel, some of your friends, teenage friends, have figured out a way to take your father's technology and use it for their own devices. Devices quite literally, really. Tell us about that.
In class, my friends tend to be sending text messages to one another, and the teacher cannot hear the text alert.
Because it's at this high frequency.
Yes, and well, the Teen Buzz ringtone is a lower frequency than my dad's invention, the Mosquito Teen Repeller. So, unlike the mosquito, some teachers can hear the ringtone, but most can't.
So you can tell maybe the age, you can gauge the age of your teachers maybe, or at least their hearing response by whether they're cracking down in class.
Yes, it tends to be about 30. The limit to my dad's invention is 20 years old.
But you're finding that if a teacher is 30 or older, they probably won't hear this ring. If they're 30 or under, they will?
Yes, my English teacher can hear it, and she's about 35.
Well, Howard, explain how it is that your device, the Mosquito Teen Repeller, has morphed into a ringtone on a teenager's cell phone. How does that work?
I dare say some kids went to the local shop where I installed one of my first devices and tried to record it using their mobile phone. I became aware of it, ran home and checked to see if it could actually be recorded, and due to the electronic limitations of the phone, my Mosquito device can't be directly recorded, so they've obviously played around on a computer and generated a frequency.
Kayaknya it just tells about the mosquito teen repellent, but we have to know the exact sound. It's not the exact sounds of the mosquito teen repellent. Yeah. We cannot hear the sound. Probably I cannot hear, but you can. you're still curious about the sounds, just look, just googling it by yourself. Okay. Then the third is the temperature, the heat and the cold stress. Heat and cold can impact workers' effectiveness, safety, the heat exhaustion, and the health. Yeah. Heat can come from the outdoor work environment in summertime, or heat, or an in high temperature of lack of ventilation indoors. Office in mechanical engineering, something when heat is still on, like the mesin 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 uap itu biasanya di pabrik-pabrik itu ada mesin yang gede, saya lupa namanya. Itu biasanya ada operatornya. Nah itu dia akan kepapar panas. Mesin yang mengeluarkan panas itu biasanya operatornya kena heat stress. And then radiant heat from work, glass furnace, kitchen oven in restaurant, yeah. Heat stress measurement. Core temperatures inside body should be normally around in Fahrenheit 98.6, or in Celsius probably in 35.5 until 36.5. It can be okay for us. Above 100 Fahrenheit, performance drops sharply, or above 105 Fahrenheit, sweating stops and death may follow. Heat stress, yes, something dangerous. Thermal comfort zone, 66 to 78 degrees Fahrenheit. So heat exchange between body and environment, we have to follow this calculation. Therefore, the thermal neutrality S should be 0. Heat stress measurement, we use the wet bulb globe temperature if the heat is in radiation. We use the wet bulb globe temperature. Okay, control environment. For indoors, we have to use the ventilation. Yeah, need 300 cubic feet fresh air per person per hour. Heating, cooling, humidity control. Sometimes not just temperature, but the humidity or the airflow. Yeah, it can influence the condition of the rooms. Administrative, limit time in hot or cold situation. Provide rest breaks at appropriate intervals in temperature control environment. So we have to avoid heat stress or hypothermic condition. The shift work. Yeah, shift work, working at times other than daytime work hours. Yeah, helps keep factories working and service. This is firefighters. Perhaps this is firefighters, police, nurse, etc. Going 24 hours a day. The problem, the shift work is hard on the circadian rhythms. You already get the slides about the circadian rhythm, right, in the biology. Yeah, change in body temperature, heart rate, and energy levels over 24 hours. So the impact of the shift work on the body. Most people's circadian cycle is 25 hours. The circadian rhythms are set by the sun. Yeah. Even though we think that in America it's different, when in Indonesia is in daylight, perhaps in America it's night condition. So it's okay when we just go to bed in 12 o'clock at the night, or just in 1 p.m. at the night. It's okay. American people do the same. We can just change our bedtime to the daytime. but it's not. It's depend on the sun.
I have a question. Is it fine if we sleep? We like change our sleep schedule. For example, like human average sleep time is 8 hours, right?
Yeah.
So, for example, if the regular time is like 10 sleeping at 10 p.m. and then wake up at 6 or maybe at 5. But is it fine if we sleep like at 3 a.m. for example, and when we wake up on the afternoon, we're still in 8 hours?
Yeah, I already said it's because the sun. So I will show you, perhaps just recall our knowledge for advance. This is the circadian rhythms. Yeah. The definition is the natural physiological means like our heart, our lung, our kidneys or something. Yeah. The body goes through everything. Function best during the daylight hours. Yeah. This is the function during best daylight hours 4 a.m. until 6 p.m. It's just approximately. Sleep best at night 6 p.m. until 4 a.m. It's just approximately. Like you can go to bed at 9 p.m. then wake up at 5 p.m. 5 a.m. It's okay. We can see in this graphic the body temperature. Yeah. This is in the daylight and this is in the night. Yeah. We get low in the night and high in the daylight. The error on the performance, you get low in the daylight but high in the night. The melatonin, do you still remember the melatonin? The hormones, the sleep hormones. We can produce the melatonin hormones at daylight. Yeah. At night, I mean at night, but in daylight, melatonin cannot produce. We cannot produce melatonin in daylight. Just in the night, in the night condition. Sorry. The cortisol. This is a hormone that we have to avoid if the frequency or the intensity is too high. We have to avoid this. So it can be okay in the night. We use cortisol high in daylight for work or for some activities, but they get low in night, and we have to make it still low. Don't make it higher in night because it can be affect our body condition. The growth hormone can up at night, not in a daylight. So when you want to still growing, not for kids, but for us, for adults, growth hormones, it can maintain our body condition, metabolism or something. So when you want to make it good growth hormone in saya lupa, ngeluarin tuh kalau hormon itu apa? Releasing the hormones, the growth hormones and the melatonin hormones. We have to in a sleep condition at night. The melatonin is very sensitive with light. So when you go to bed, just turn off light. Very sensitive, even a small intensity of light, it can affect our melatonin. You want to still make it young and have a good metabolism or something, you have to go sleep well in 7 until 8 hours in night condition. You can change it 8 hours, but in daylight, yeah, daylight condition. So we cannot do that. Okay, so you understand with this? Shift work, impact of the shift work. Yeah. People on shift work never truly adjust. The sun keeps their body set on the day schedule, even when they have to work at night. Circadian rhythms of shift worker laden. Yeah. Shift worker experience health problems, disruption in social life, yeah, greater accident rate. This is the types of shift. Yeah. Actually, it can be more complex or complete in circadian rhythm slide presentation. You can study at that presentation, not in here. It just for the brief information. Yeah. Guideline, and then the overtime. And the last is about the radiation, the unit of absorbed radiation dose in the brain. Yeah, like workers, radiation from the cell phone, it's debatable, but for better, we just avoid the radiation from the phone. Close to microwave frequencies, cell phone frequencies, non-ionizing radiation or something, medical and dental treatments, nuclear testing and dumping. Perhaps after finish your education in here, you work at Fukushima nuclear testing or something, we don't know. This is radon gas, yeah, for radiation. Yeah, you are always exposed to some level of naturally occurring background radiation. Cosmic rays, something, yeah. This is the radioactive products and the workplace radiation. Nuclear power plants, uranium mining and processing, X-ray and chemotherapy technicians, awesome. We don't know. Okay, is there any question with these materials? Is it clear? Okay, this is clear. Perhaps you can combine this information in this slide presentation with the biology slide presentation, sensory and circadian rhythm at work.